So today's topic is half-range Fourier series. So half-range Fourier series means suppose our function, given function, is defined in an interval 0 to L. For example, if we have a like in real life example, if we have a string 0 to string of length L, if we define the displacement of the string as f of x, then that means length of this string is L. So this is an half range, only 0 to L. So for such cases, it is immaterial whatever the function may be outside, whatever may be the function may be outside 0 to L. Okay, so the interval 0 to L, to get series of cosine only, we may assume that function f of x is an even function in the interval minus L to L. That means whatever the function given on 0 to L, f of x is defined on 0 to L. What we will do is we will extend this f of x to minus L to L. And if we want to get a series of cosine terms only, we know that when we will get a series of cosine terms, if the function
The function is
even
even.
function. So what we will do is we will extend this function as an even function. So I will give you the extension so we can extend it. If we have f of x 0 less than x less than L, then what we will do is if we define f of minus x minus L less than x less than 0, then this function must be an even function. So if we define like this. So what we will do is in order to define this function outside my 0 to L, such that we are defining this function on minus L to L. If we want it as an even function, we just define like this f of x from 0 to L and f of minus x when minus x minus L less than x less than. Then the extended function must be an even function. Then we know that what is a naught even function, then a naught is 2 by L integral 0 to L f of x dx, and an is an is 2 by L integral 0 to L f of x cos n pi x by L dx, and we know that Bn is equal to 0. So Bn is equal to 0. So if we extend this function as an even function, we doesn't want this extension, but I told you how to extend this. So if for doing problems, we never do such extension. We will assume that we are extending as an even function to get a series of cosine terms. Now, in order to expand f of x as a sine series, we extend the function on the interval minus to L to L. To get a sine series, what extension is we need? We need f of x to be extended as a even or odd function to get sine series.
Odd function.
Odd function. So that means we can extend f of x as an odd function in the interval minus L to L. And I told you that we can do that because if you take f of x, some extended function like f of x, we know that it is defined on, and if we define f of minus x, then 0 less minus L less than x less than. This is odd extension and this is even extension. So we can prove that if we extend like this, f of x is equal to, I will do one. Okay, we can check whether it is even or odd. 0 less than x less than 1, L f of minus x minus L less than x less than 0. Okay, So what we will do is f of minus x is equal to, if we extend this, f of minus x, instead of x we have minus x, then we have f of minus x 0 less than minus x less than L. So what do you mean by 0 less than minus x less than L? Which means if you multiply both sides by minus 1, then L less than minus L less than x less than 0. Right. So what you will get is here minus L less than x less than 0. Now if I apply instead of minus x, if we apply minus x. So minus x is plus x, and we have minus L less than minus x less than 0. So what do you mean by this? If you multiply both sides by all sides by minus 1, you will get 0 less than x less than 1. So that means what we get is minus 0 less than x less than n. So what is f of minus x? This is simply as f of, so this is an even extension. So have you got it? So we can extend any function from 0 to L in such a way that it is an even extension. So we, while doing problems, we will not do this extension. We will just assume that the function can be extended as even, and we will find an, bn and a0. Bn is already 0. So if it is an even function. Similarly, we can extend it as an odd extension. Any doubt? This is a somewhat a difficult concept. If you have any doubt, you can ask me. Similarly, you can extend odd extension, you will get minus. Anybody have any doubt? Is it clear? So this is very important section. There must be a question find Fourier sine series. Okay. So half range Fourier series, sine series is called, either it is called half range sine series. Sorry, first one. If it is even extension, half range for a sine and cosine series, Fourier cosine series, or simply it will call cosine series. So cosine series means that must be, if it is defined on the interval 0 to L, that must be half range Fourier cosine series. Sine series, then if it is defined on 0 to L, then it will be half range sine series. So we will do a problem. So this is very important problem. Find Fourier sine series for the function f of x is equal to e raised to ax for 0 less than x less than pi, where a is a constant. So here given that Fourier sine series, right? Fourier sine series. So that means half range Fourier sine series. So Fourier sine series means half range Fourier sine series. And it is defined on the interval 0 to pi. That means 0 to L. So L is pi here. Okay. So 0 to L. So that means it is defined on the interval 0. So we will do this problem. So given f of x equal to e raised to ax, a is a constant on the interval 0 less than x less than pi, and we know that from this interval we get L equal to pi. And we want to find out sine series. So Fourier sine series means you know that it's a sine extension. So we will get Bn is equal to this, and an is equal to 0 and a naught is equal to 0. Okay. So Fourier sine extension, so which is equal to, so here the Fourier sine extension, therefore the Fourier Fourier sine series is of the form, or a half range series. Fourier sine series means half range Fourier series. Half range Fourier sine series is of the form, you know that f of x is equal to, you can written as sine series means only sine term, sigma n equal to 1 to infinity bn sin n pi x by l, and bn is, it's a odd extension, 2 by l integral 0 to l f of x cos n pi, f of x sin n pi x by l d. So now we will find out bn. Okay, so for in order to find out bn, so we already have a formula, right? Okay, so first we will write what is bn. Bn is equal to 2 by l integral 0 to l f of x cos, sorry, sin n pi x by l dx. So this is equal to 2 by l is pi integral 0 to pi f of x is e raised to ax sin n pi x by l. L is again pi dx. So pi and pi get cancelled, which is equal to, which implies bn is equal to 2 by pi integral 0 to pi e raised to ax sin nx dx. So we already know this formula. Integral e raised to ax sin bx dx is equal to this, right? E raised to ax divided by a square plus b square into a into b sin bx minus b into cos bx. So this is equal to, so here instead of a itself, and instead of b, b equal to n, right? So this is e raised to ax divided by using this formula, a square plus n square into a sin nx minus b is again n cos nx. 2 by pi is in outside, right? 2 by, and we will limit of integration is 0 to pi. So now which implies bn is equal to, so 2 by pi, you can take an outside a square plus n square, a square plus n square, e raised to ax a sin nx minus n cos nx 0 to pi. So which is equal to 2 by pi into a square plus n square. So when I given the limit pi, upper limit e raised to a pi a sin n pi, sin n pi minus n n n cos n pi, okay, minus, if I put a lower limit, e raised to a into 0 a sin n 0 minus n cos n into 0. So this is equal to 2 by pi into a square plus n square e raised to a pi sin n pi. Sin n pi, we know that sin n pi is equal to 0. 0 minus n into cos n pi. cos n pi is equal to minus 1 power n. N into minus 1 power n minus of e raised to 0 1 into a sin 0 0 minus n cos 0 n 1. So minus n. So the answer you will get Bn is equal to Bn is equal to okay. So this is equal to 2 by pi a square plus n square e raised to a pi minus n minus 1 power n plus n. So this is the Bn. So Bn is equal to this. So if we want to simplify this, you will get the answer 2n a square plus n square pi 1 minus. Okay, so I will so I can take it to n outside, right? 2n divided by pi a square plus n square e raised to a pi minus 1 power n 1 minus 1 power minus 1 power. So this is b. So let us check that. So Bn is answer is 2n a square plus n square pi 1 minus 1 power n e raised to a pi. So what is our answer? Correct, right? 1 minus 1 minus 1 power n e raised to. So our answer is this. So f of x Fourier sine series is equal to f of x is equal to, so f of x is here e raised to ax is equal to 2n by pi a square plus n square, sorry, sigma n equal to 1 to infinity 1 minus e raised to a pi minus 1 power n sin nx. So this is the answer. So this is Fourier sine series. So
Sir,